sure. All right. You should have been able to use your Ka to identify your acid. That acid should have been acetic. Hopefully you had a Ka that came in this range. All right. So we're going to start by writing a net ionic equation for this lab. So what happened was we had an HA, which was our acetic acid. It had OH that it came in reacted with. We formed water then, and we formed A minus. So that should be your reaction for this lab. Now, we are going to rewrite that as our value for our BCA table. Okay, so here is my BCA table. I'm going to have HA plus OH minus. I'm going to have water over here, and I'm going to have A minus. We don't care about this one. We're going to have BCA here. Okay. We are solving here for X. We don't know what X is. We have added in a certain amount of OH. So you need to find your value from here, which you should have done one of those linear regressions to find out what your base volume at equivalence point was. Okay, so go back to your chart, find your base at equivalence. Have you found that value? Yes? No? Maybe? Use that value then to calculate how many moles of 0.2 molar base you use. So my value here that I'm going to be using for mine is 15.87346. That's what I'm using for mine. So I would take 0.2 times, I got to take this out of milliliters and put it into liters. Okay, and with that, then I will come out and I will get 0.2 times 0.01587346. I'm going to come out with 0.00317. Did you check in with attendance or somebody else?
No attendance.
Okay. All right. Well, that's fine. I just didn't know how I needed to approach it. So if you go through attendance, I don't need to do anything. If it's from another teacher, I do. All right. So this is going to be my moles of OH. So I'm going to put that over here in my chart. So that is going to be 0.003175. All right. So then over here, we will have whatever we used on this side is what we're going to end up forming on this side. So we're going to plus 0.003175, which means that we will have created that much of the conjugate base. I will have used up that amount here. And I will used up that amount here. That means that I have none of this left, and I have X minus that. Okay. All right. So you spend a minute getting this table done, and then we'll move on to the next step. We're going to follow through and do all of this together. Okay.
So Libby, to get the moles, you took 0.2 times the base volume and put 1 point.
Yep.
Okay.
Because the molarity of the base was 0.2, and this is the volume. So if I multiply the molarity of the base times how much of it I use, that's going to give me my moles of my base. And remember, in BCA tables, you have to have moles in here.
Oh, but we put the base volume. Did we put that as milliliters? So then
it was in milliliters, so I had to convert it into liters here. I don't know if that's confusing that I didn't put a leading zero there.
I just didn't label it as milliliters, so I put 16.
Yeah, this is liters here, and this would be molarity. So if I multiply those together, that's going to give me my moles, which was the moles of OH, which is also the moles of this stuff that I created. Okay. Anybody need another minute to get that table filled out, or are you ready to go with me? All right. Now we are going to follow through all of this. So I'm going to start by writing my I'm going to start by writing the dissociation equation for this guy. So I'm breaking apart this acid into H plus or H3O plus, if you'd rather think of it that way, and a minus. So that is my dissociation equation. Okay. I need to calculate my H concentration at equivalence using this value. So I am going to go back to my table here. Hopefully you did a linear regression to get your equivalence point here, and then did another one to get the pH at the equivalence point. Does anybody need me to show you how to do a linear regression again to get the pH at equivalence point? Okay. So the pH that I'm going to be using here is 9.25. All right. If I take, does anybody need time to get that value? Everybody has their pH at equivalence point filled in? Okay. So if I take 10 to the negative 9.25, all right, if I take 10 to the negative 9.25, that's going to give me my H plus, right? No. Yeah, it gives me the H plus. So this to that gives me my H plus. Okay, so that's going to give me, on my calculations, is 5.59 times 10 to the minus 10. All right. Good. That's my molarity. I then need to figure out for this guy what it is. So what I'm essentially doing here, I'm not even going to bother with an ice table necessarily. I'm just going to do the Ka expression, okay? So my Ka is going to equal this, okay? The 1.8 times 10 to the negative 5. Which equals this guy times this guy divided by that guy. So I'm going to take this value, that's my 5.59 times 10 to the minus 10, and I am going to multiply it by, what happened there? Ah, freaky thing. Seriously, come on, there we go. And I'm doing big brackets here because I've got to get a volume and moles on top here. So I got to have a lot of room. So I'm going to take that value came down from here. This value then is my A minus. That's my moles of A minus that I have available. Okay, so I'm going to bring that number down, 0.003175. 0.003175. I'm bringing that value down to here. That's going to be my moles. And then I need liters on the bottom. So how many combined liters do we have? You have to find out how much you used of your acid. So your acid volume here added to your base volume. You've got to add those two things together. This was probably 30 or right around in there, and you're going to add it to the base at equivalence point. Right? So for me, this is going to be 0.04587,346. Okay. And then on the bottom, you're going to have X minus 0.003175 over that volume again. You will go through and you will solve for X. You can either use a fancy equation solver on your calculator, or you can do the math, your way, however you want to use your algebra. But that X then is going to equal the moles of HA. If you then divide that by the liters of HA that you started with, which was probably around 30 milliliters, but you've got to convert it into liters, that will give you the molarity of HA. Fun times, huh? Now, the next thing that you have to do is percent ionization. Okay, so percent ionization then, percent ionization is going to be from this equation. Okay, you know that this is whatever answer you got up here. So you've got to bring that answer down. Okay, that was your final molarity up here. You're going to bring that molarity down to this point. This then will be X and X. So 1.8 times 10 to the minus 5 is going to equal X squared over the molarity of that HA from the previous problem. Once you solve for X, then X over the concentration of HA times 100 will equal your percent ionization. The correct molarity for this year for your weak acid then was 0.01, I'm sorry, 0.1 molar acetic acid. Okay. That molarity might vary from year to year, just so you know that. But for this year, that's what it was. All right. Fun times.